So in this section, we will learn some strategy to simplify some calculation of definite integral. The first theorem is regarding the sum of two functions. Okay, so the integral of f plus g is the same as the integral of f plus the integral of g over the same interval. The advantage of this is that we break down more complicated function into smaller and easier to manage function. The next theorem, okay, if you multiply a function by a constant and then integrate, it's the same as you integrate the function first, then multiply by a constant. The advantage of this is sometimes it's easier to integrate with smaller number and then at the end multiply. And then the next theorem, and it's going to be handy also, okay, it will help us to break down integral into different intervals. So for example, the integral of f of x from a to b plus the integral from b to c of f of x is the same as the integral from the entire interval a to c. And if you draw a picture, so this is a function, okay, integral from a to b is the area here, and integral from b to c is the area here. But then the integral from a to c is the entire area under the curve. Now the next theorem, pay attention, okay? The integration limit is from a to b f of x dx. But then if you switch the limit from b to a, you flip it, it will become negative. So how is that? Well, from the fundamental theorem of calculus, the left-hand side is the antiderivative at b minus the antiderivative at a. But this one, okay, is the antiderivative from a minus the antiderivative from b. But if you take the negative sign, it will become fb minus f of a. That's why this works. So keep these theorems in mind. We want to evaluate this integral. Now at the first glance, you will say, I do not know the antiderivative of x minus 1 divided by square root of x. So what can we do? We want to see, can we break it down into smaller and manageable functions? So we begin by breaking the fraction into smaller fraction, okay? So it's x divided by square root of x is just x to the 1/2 power minus 1 over square root of x, so it's x to the 1/2 power dx. Now this is a difference of two functions, and you can also think of it as the sum of two functions. One is with a negative sign. So we can break it down into a smaller integral, and you integrate term by term. So the first function is x divided by x to the 1/2 power. So we subtract the exponent, so x to the first power divided by x to the 1/2 is just x to the 1/2 power dx. Then we subtract the integral from 1 to 9. 1 over x to the 1/2 power is the same as x to the negative 1/2 power dx. Now once we break it down, we want to use the power rule. So it is the antiderivative of x to 1/2 power is you increase the power 3 over 2. Now you divide it by the new power is the same as multiply by the reciprocal, and you evaluate at 9 and 1. Then the next one, okay, you subtract the antiderivative of x to the negative 1/2 is x to the 1/2 power, because you increase it by 1, and then you multiply by the reciprocal, you evaluate from 1 to 9. Now it's just a matter of plugging in numbers. So you plug in 9, okay, so 2/3 times 9 to the 3/2 power. So you have to use a calculator. Is 58/3. And then you subtract, when you plug in 1, it's just 2/3. So that is the first integral. Then you subtract the second integral. 2 times 9 to the 1/2 power is 6, minus 2 times 1 is 2. And it's important that you you evaluate one thing at a time and keep the sign. Otherwise, you get confused on, okay, do I subtract or do I add? So now, it's just a simple calculation. You plug it into your calculator, okay, or you do it by hand. Either way, the final answer you will get is 40/3.